You might have seen the weird text-to-speech AI from AI SpongeBob or the insanely good AI Drake songs and wondered, what are all these AIs? And how can they be so good and so bad at the same time? Well, today I will be here to demystify everything for you. Let's break down what all the AI technologies people are using, what resources are actually available to you, and how people have made Donald Trump and Joe Biden play Overwatch together. But first, in order to differentiate them easier, we will need to dig a bit into how they actually work and what makes all of them different from each other. Currently, voice, speech, saying, or whatever generation you might call it can be generalized into two main categories. The first one is the classic text-to-speech synthesis, or what I like to call it pure text-to-speech. This is pretty straightforward. It's like Siri replying to you, or the TikTok text-to-speech for commentating videos, because the AI only uses text to generate the audio. But the AIs that I'm talking about today are the ones that let you generate your own custom voices, which is much cooler. But the coolest is definitely the second category, voice-to-voice conversion. This is the one that enables AI-generated singing, which is how the AI Drake song was made. If you don't know the infamous AI Drake song, go search it real quick because it's surprisingly good. I just can't play it here because that song has become a DMC landmine. The music record did not take that well for sure. Anyways, this type of speech or even voice synthesis requires an audio reference as an input. So how AI Drake was made was that you basically take someone's vocal like Drake's, throw it into the AI to train and learn his voice, then have a person sing a song and the AI would able to use that singing to convert the person's vocal into Drake's. The small but significant difference between the two is that pure text-to-speech doesn't let you imitate sounds or style of speech. So if you want to make sounds like oh or speak in a certain tone, only voice-to-voice will be able to copy that since text-to-voice only reads text, and those things cannot be accurately expressed through text. So now you know the two main types of voice cloning, you probably would want to try them out now. But before I start information dump you about what's the best app or services, let's talk about the backbones or basically the research papers that carry most of the voice cloning tools right now so you would understand your options a lot more. For text-to-voice synthesis, there are two main research that is currently the most popular. The first one is Tacotron 2, which is the one that you are listening to right now. Its research was published by Google and built by Nvidia back in 2018, and it's the one that AI SpongeBob uses to do all the text-to-speech in the live stream. The main advantage is that it's fast, but the trade-off is that the quality is just not up there. What's worse for Tacotron 2 though is that it needs to be fine-tuned for around 2 to 3 days to copy someone's voice decently, and people usually use around 3 hours of the target voice data, so it would definitely be the last option for some. However, since Tacotron 2 is pretty old, it has one of the largest custom voice libraries online, and I'll talk about those libraries or services later. Second one is TorToiSe TTS, which is probably the most popular research or backbone for most of the voice cloning programs. Developed by James Becker, this bad boy can fit so many voices in it because it only needs around 30 minutes of data and 30 minutes of training time. And this is how a 30 minutes data and 30 minutes of training sounds. The main downside is that since TorToiSe is diffusion based, it is much slower at generating voices, especially if you are not running it on a GPU. So if you want something high quality, the worst case could be it taking 10 minutes to render just one sentence. However, the quality is much better than Tacotron 2 and would retain better consistencies of the voice that it's copying from. The problem is that it'll sometimes act up and reread a sentence twice if your training data is flawed, which is pretty funny.
How can they be so good and so bad at the same time? And how can they be so good and so bad at the same time?
But what about their frequencies and audio quality? Are they the same? Well, actually, there is something else that is handling this task. You see, these two AI models are the synthesis module, where the AI converts the text into audio spectrograms, more specifically, mel spectrograms. Audio frequencies are generated by a second module called the vocoder, where the AI generates audio waveform from those audio spectrograms. There are loads of vocoders like WaveNet or WaveGlow, but the most popular one right now is called HiFiGaN, where pretty much most of the synthesizer uses it. HiFiGaN is popular because of its superior performance in generating high-fidelity, natural-sounding speech. It is designed to create high-resolution, high-quality audio waveforms from mel spectrograms with an incredible speed, and depending on what frequencies the synthesizer is trained on. We can generate from 22 kHz up to 48 kHz. It does this using a generator and discriminator architecture similar to GANs, but with several enhancements specifically for audio synthesis. However, some people choose to use other vocoders for different synthesizers because there are other models like BigFiGaN. Because this vocoder sounds better for text-to-speech synthesizers, and there are also super sampling techniques to upscale audio from 22K to 32 kHz, but these are definitely a bit too complicated and a story for another day. These vocoders are also used in voice-to-voice conversions with roughly the same logic. which is a perfect time for me to introduce you to the two main popular options for voice-to-voice conversions. These are the ones that can get insane audio quality like up to 48 kHz because it doesn't use text to synthesize at all. The lore of these AIs are a bit complicated because they are like research on top of implementations on top of more implementations. So I'm gonna be lazy and choose the easy way to refer to them as AI software. The first one is SoVits SVC, which stands for Soft VC Vits Singing Voice Conversion. As the name suggests, the main characters of this software are Soft VC and Vits to achieve the voice-to-voice conversions, with a bunch of other side characters like parts of Diff Singer, Hubert, and Hi-Fi Gen to support this function. With each update, they often reorganize or change the combinations and designs of its AI architecture, so it's really hard going into details and not get outdated in like a month. For reference, this is VI SVC, another type of implementation that combines Vits with other AI architectures, and they take apart, recombine, or redesign them every other version. It can get really messy for any non-researchers looking at it, so yeah, let's not go into it. Right now, SoVits SVC is probably the most popular one with over 16.8k stars on GitHub. However, the second one, RVC, short for Retrieval-Based Voice Conversion, which is like a direct successor of SoVits SVC, may be a better choice. Released on March 23rd, 2023, a few days later than SoVits SVC, it can generate more consistent and accurate vocals and is just hands down a better package with faster training time, needs less amount of data, and lower hardware requirements. It was technically better than SVC, especially quality-wise. Before SVC used an encoder called Hubert, and RVC uses Content VEC, which is a better version of Hubert, with the addition of a retrieval functionality within RVC that can reduce tone leakage. However, with the latest SoVits SVC 4.0 update, they both now use similar components and architectures, and some people would still prefer SVC because it has a bigger community surrounding it. I am pretty sure that RVC is the technology behind the AI Drake song, because back when it was made, SVC's quality was definitely not the tech behind it. What do you think about the audio quality difference?
What's up guys, welcome back to another episode of the AI Timeline.
What's up guys, welcome back to another episode of the AI Timeline,
Where I cover the coolest AI developments in the past week.
Pure singing and pure speech can make a difference too, so here's a quick singing comparison.
Legends now overjoy.
Legends now overjoy.
And you hear them screaming now tonight.
Can you hear them screaming out tonight?
It's also interesting to note that the developing community for all the top-tier text-to-speech research are mostly made by US researchers, and most of the top-tier voice conversions and related papers are all published or made by Chinese researchers. The SVC and RVC GitHub page are originally Chinese too. It's funny how there are different priorities for researchers with different cultures. What's that sound? Oh my god, it's TalkNet. It's TalkNet, guys, we forgot about it. TalkNet is a text-to-speech synthesis research, but with the ability to also input an alphabet, which is a pronunciation notation to specify a sound. I've made a video about it, you can check it out if you're interested. I am not gonna cover it in this video since it ain't the best now. Alright, since now we know these all backbones, it's time to move on to services and the most popular ones to see what they are about. Oh, and I am not sponsored by any of them. UberDuck probably has the largest online library for both text-to-speech and voice-to-voice models, but unfortunately in a recent update they have removed all the users upload models from their website and have turned into a commercial-friendly service instead, potentially due to the amount of takedowns for their voice clone models from the Universal Music Group. So a moment of silence for UberDuck. And there's FakeU, which is another similar service with 3000 plus Tacotron 2 TTS models and 400 plus SVC models, and has a pretty nice user interface. Its library is slightly smaller compared to UberDuck and it'll let you generate for free, but you would usually have to wait in a very long queue. Additionally, free TTS is only limited to 12 seconds. It also has a wave to lip video lip syncing service where you input an audio and it'll lip sync the person in the video to that audio for you. So the paid subscriptions are pretty much getting you off the queue. They're planning to support RVC models very soon too. It's important to note that 2 of the above services do not offer any voice cloning, and you would only be able to use the pre-trained models uploaded by other people. This may be because custom voice clone like Tacotron 2 or SVC requires too much hardware, so they did not make them as an available service. However, the last service does offer voice cloning, but not for singing, only text-to-speech. ElevenLabs, which you might have heard of given its extreme ease of copying and cloning voices, took the internet by storm a few months ago. The infamous Biden, Trump, and Obama playing Overwatch is probably made with ElevenLabs too. I actually think its backbone is TorToiSe based because just listen to these two audio clips.
You might have seen the weird text-to-speech AI from AI SpongeBob.
ElevenLabs offers a few basic things, but the highlight is basically the voice cloning function it has. In its instant voice cloning function, with just taking in around 1 minute of voice as an example, it can clone the voice pretty well, probably the best quality out of all the current existing tools. However, there is a downside where the voice that you're cloning has to be fluent in English, or else if the voice like mine was used, it can sound a bit weird and unnatural. They have recently just released an English V2 model, so it definitely sounds a lot better compared to English V1. I think they are planning to release a new voice conversion function, but the details are still unclear. They do have another special function called professional voice cloning, where you would give them around 80 minutes of voice data and they would clone it for you. However, it is only limited to one voice for a $22 per month subscription right now, and if you do not want to pay anything, especially if you just want to clone your voice, there are free local UIs you can use, which is perfect if you have a computer that has at least 8 GB of VRAM. For Tacotron 2, check out this voice cloning app. You can basically do most of the stuff about Tacotron 2 on here, and the wiki has made it pretty straightforward too. It includes tools to help you sort and organize your data before training, load other pre-trained models, and generate results. If you need a tutorial, check out this one made by the author of this GUI. I forgot to mention all the training data for any of these requires the speaker voices without any background noises. So if you do need to separate voice from music or noise, check out this tool. For TorToiSe TTS, check out this repo called AI Voice Cloning made by MRQ. This is probably the most actively maintained TorToiSe web UI on the internet, and it has most of the stuff you would also need, including training and inferencing. Check out this tutorial to learn how to use it. For SoVits SVC, check out this GUI, and this tutorial is made perfectly for it. For RVC, the official web UI is already good enough and is actively maintained, so definitely use that. You can check out this tutorial to learn how to use it too. Alright, that was probably the most boring information dump I've ever made, but hear me out, there's more good stuff coming. Since voice-to-voice conversion requires a reference audio, what if you use the text-to-speech result as the reference audio so you can have a fully text-to-speech AI with way better quality without the need of a reference? The custom pipeline of combining TorToiSe result and using it as a reference for RVC to generate a unpure text-to-speech is completely possible. So if you take two voice clone models like TorToiSe and RVC and use the TorToiSe output as an input for RVC, then I technically do not need myself to narrate my script. I can have TorToiSe read and maintain most of my style speech while RVC smooths the audio out, which is exactly what I did for this video's narration. Some of you might have already realized, but yes, none of the audio in this video is a recording of my voice. This is how my voice actually sounds. Pretty cool, right? What I would need to correct myself though was that I used a TorToiSe model that was trained on 4 hours of my voice with around 4,500 iterations, which is like 11 hours of training time on a 4080. Shout out to Synthetic Voices for helping me out with this. Right now, I think there are a lot of great ways to utilize this AI tech, like helping content creators to translate their content to another language while maintaining their own voice. On top of that, syncing lips ain't that difficult too thanks to AI. And if you already have a voice actor, voice-to-voice might just do the perfect job. So with the team that I've worked with in this video, I think it's totally possible to create a custom tailored pipeline for everyone. If you're a content creator and are interested in this, shoot me a DM on Twitter and maybe I can make a few demos for you. Okay, just a few days before publishing this video, I have just received a message from ElevenLabs that the Pro fine-tune voice cloning, which every account is limited to only one voice, has been completed. This took somewhere around 1.5 hours of my clear voice to fine-tune, unlike its standard voice cloning that only takes like 1 minute long of reference voice. And to answer the age-old question, which one is the best? Well, in my opinion, ElevenLabs took way less effort to use since I can just paste a whole paragraph into it and it'll generate everything coherently without any bugs, while TorToiSe plus RVC needs to do 2 manual passes for each sentence, and you have to double check if they have generated correctly because it can screw up very easily. No need to tidy up transcriptions before training and whatsoever, so this is probably the most convenient option. I can't really say that it's also the faster option because I don't know how long it was trained on, and ElevenLabs gave me no specific time frame of when this would be done. If I recall correctly, I submitted this nearly 2 months ago and only got it today too. However, the inference time seems to be really fast. I only had to wait like 10 seconds before before it started generating and continuously expanding the voice audio for 3 paragraphs. However, if you are looking for the best quality and resemblance in pure text voice cloning, TorToiSe plus RVC combo is unbeatable. I think you might have picked up by now, and yes, the audio you are hearing for this additional comparison is fully generated by ElevenLabs Pro voice cloning, not the combo. So I do think quality-wise, this is not as good as the open source and the free option right now.
I think it may be the problem with the vocoder, which I mentioned before, where it'll perform better on people with less accents, and it'll probably work best on native speakers. But the downside of the combo is that it takes too much data, too much time, and too much effort to get everything right, so it really depends on how much time you have. For better quality but takes longer and more effort would be the TorToiSe plus RVC combo. For the quicker with less superior quality but a lot more convenient would be ElevenLabs Pro voice cloning. And this voice clone is only trained on 1 minute of Asmongold's voice, so ElevenLabs may be better in this case. Holy shit! This voice clone is just too real. Please subscribe to BuyCloud. I'll give it back to him. I think he'll talk about some sponsors or something.
And today's video is brought to you by Brilliant.org. You know, I've actually been asked a lot of times about where to start learning the fundamentals of AI and machine learning. And you know what I always say? YouTube videos, because they are free. But free content comes with compromises. The cheap quality of the learning content, the difficulty in interacting with the learning materials, or the unclear and roadmap to master the field is not always there. So this is where Brilliant.org comes in. Not only that, Brilliant also provides a clear roadmap on different subjects for all knowledge levels. From basic algebra to advanced multivariable calculus, from programming with Python to artificial neural networks, Brilliant is full of STEM courses that are usually a pain to study in, but made into a much friendlier and digestible format. I had actually used it a lot during my time in high school too. It helped me when I got introduced into the cursed world of calculus and somehow helped me to survive it because it made understanding the difficult concepts much easier with these very intuitive interactive lessons. So yeah, quickly get started on Brilliant by heading to brilliant.org/buycloud to get started for a free 30 days experience with Brilliant's ever-expanding interactive lessons, and the first 200 people to sign up will get a 20% off an annual membership. Thank you Brilliant for sponsoring this video. A big shout out to Andrew Lescelius, Chris LeDoux, Alex J, Alex Maurice, Deagan, Miguilim, FiFaŁ, and many others that support me through Patreon or YouTube. Follow me on Twitter if you haven't, and I'll see you all in the next one.